Okay, so we're going to talk about some characteristics of exponential functions, so we're going to start off with the domain and the range. So the domain, which is your x values, is all real numbers. We saw this in the previous video when we did the graphing stuff, where you can have x's negative numbers, x's positive numbers. Now we stuck with whole numbers, but it can also be fractions, decimals, things like that. So the domain is all real numbers or negative infinity to infinity. And the range is going to be 0 to infinity. Note here that the 0 is open on this end. It does not include 0. We saw that, or we saw that taper tail on the graph. You're never going to get something that's going to result in a negative answer off of a basic traditional starter exponential function. Now, every graph, no matter what the base is always going to go through the point 0, 1. And that's, again, we talked about this rule in a previous video, is that anything to the 0 is 1, so long as that base isn't 0. With exponentials, we're not allowed to pick a base of 0 anyways, because it's got to be positive, and so that's never going to be an issue for us. So we're always going to be utilizing the point 0, 1. Now, if b is greater than 1, so that was our example where we did 2 to the x, then the graph is going to increase or get higher as it goes to the right-hand side. If that base is between 0 and 1, so it's smaller than 1, still staying on the positive side, then the graph is going to decrease as it goes to the right. We're going to see that taper tail going towards the right. Now, this function is what's called 1 to 1. Now, what 1 to 1 means is that every y value answer only has one x value input. So you cannot have two x's that go to the same y. It's already a function because our x's don't repeat. Now, later on, we'll talk about what this inverse is. It does have an inverse that is also a function. We talked about previously when we discussed inverses, that horizontal line test. This does pass a horizontal line test. So it does have an inverse function. Now, the last one is the graph approaches but never touches the x-axis. So it does have a horizontal asymptote at y equals 0. Now, we're going to talk about some transformations that can occur with this. Okay, so we can have vertical shifts. Now, if you will think about this from when we did our quadratic ones, okay, we see some very, very similar things here. If they want to move this graph up or down, then it's going to be done at the very end of the equation. So we've got plus c is up and minus c is down. Very similar to the way we saw this done when we were talking about vertex form for a quadratic. Now, for horizontal shifts, it is going to be up in the exponent with the x, so it's going to be in that little bitty kind of superscripted font. I tend to put parentheses around mine just to help me remember that it's going to be the opposite of what I think it's supposed to be. Sometimes they may or may not put that on there, but plus is left and minus is right. Now, reflections. If they put a negative out in the front, it reflects over the x-axis. This is very commonly, and I usually use a set of parentheses between the negative and the b. Okay, because I don't want anybody to think that that negative is part of that base, which we've already established we can't have negative bases. So I'm a little, that's why I've got my stars out there next, is we got to be real careful about that notation. So that's going to be over the x-axis, so it's going to be top to bottom. And then if they put the negative with the x, then it's going to reflect it over the y-axis or side to side. Vertical stretches and shrinks, making them taller or squishing them smaller, is going to be handled in the front. Again, they may use a set of parentheses here like we saw in the first video about the going to the mall with the 42.2. Oftentimes they will use parentheses or at least like a multiplication dot or something to show that those are separated. Again, numbers bigger than 1 are going to stretch them. Numbers between 0 and 1 are going to shrink them. Horizontal stretches and shrinks are going to be done up in the exponent. And again, they're going to do the opposite of what you think it's going to do. So let's take a look at this particular one, okay? And I'm going to show you a technique for how I tend to do these, okay? So here is my grid space. Now, couple things is there are a couple of key points that I use. So I'm going to make note of these. So my key points that I use, and these are what I'm going to use to help me create my graph. Number one, I'm going to use that 0, 1 spot. The one that I know is on absolutely every single graph every single time, okay? The other one that I'm going to use is 1, comma, B, or base, okay? So whatever my base is for my particular problem, that's the one that I'm going to use. So the way that I showed this, doing this, is I'm going to go up here and I'm going to use a little X, and I'm going to mark that 0, 1. Now, the particular one that we are doing, okay, was they said use 3 to the X to graph 3 to the X minus 1. Now, first thing I'm going to do is I am going to put that little bugger in a set of parentheses, okay, just so that I know what I'm doing. So now I've got my 0, 1. 1 base for this one would be 1, 3, because 3 is my base here. Okay, so I'm going to go over here 1, 3, and I'm going to put a little X. Now, those are not going to be part of my ending graph, but that's what I'm going to utilize. Now, making use of this, it's up in the exponent, so I know that's right and left. I've put a set of parentheses on it to remind myself that this is going to be the opposite. So -1 is actually going to move this thing to the right 1. So now what I'm going to do is these two X's that were on the original 3 to the X graph, I'm going to move them both to the right 1 spot. Okay. Now, the other thing that we haven't discussed here is there is a horizontal asymptote that was sitting right here on the X-axis. If I move that to the right 1 spot, it's still going to sit on the X-axis. So I'm going to indicate that with a dashed line. We saw this technique done with our rational graphs. Okay. And now I know these two dots make it feel like I'm moving upwards. So I'm going to arch this up and then taper tail that other side. Okay. Get that out of there. Glare. Okay. So there's how we would do that. And again, any sort of movements that were done, we can use these same two. Now, again, I used 1, 3 as that other key point. If this had been a base of 5, I would have used 1, 5. If it was a half, then I would have used 1, comma, 1 half. So those are how, that's a technique that I often would utilize to help me move so that I've got at least some starter dots and I'm not trying to guess some values to plug in to try and figure out where stuff is going.